We're live. My guest today is Susannah Evans. She's product lead for IBC. Today we're diving deep into blockchain interoperability. We're going to be looking at different bridge designs and why IBC stands out. Also looking to understand how IBC works under the hood, looking at the fault isolation mechanisms that makes IBC safe, and also looking at the future of the IBC roadmap. I'm also dying to find out why she thinks animals should have stronger rights, but that the vegans are getting it wrong. So before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified when I go live every week. And remember that none of what we discuss here on the Interop is financial advice. And if you enjoy this content, please consider staking with us. We're live on Fmos, Quicksilver, very soon, very soon on Osmosis. Just look for the Interop in the active validator set. My guest, Susannah Evans, is coming up next, right here on the Interop. Hi, Susannah.
Hey, how's it going?
Hey, I'm good. How are you? Thanks for joining me on this podcast.
Yeah, I'm really glad to be here. Thanks for inviting me.
Yeah, well, so I mean, I first encountered you, I think, right around Nebular Summit last year. You were introduced to me by folks at the ICF, and you gave a talk there. And then you also gave a talk at the, or you were on a panel rather, at the event that we did in Medellin. And yeah, I've been wanting to get you on the podcast for a while because I think like you're one of these people that are really important to building out the IBC standard, but maybe are not super visible like on social media. Like
Yeah.
you're operating in the operational sense, but you have I think a really broad overview and understanding of IBC, and so it made sense for us to have a chat here and kind of like dive deep into that.
Yeah. I remember especially the pan. We also did a panel at Nebula. That one was really great. I remember.
Yeah,
It was,
yeah.
But yeah, I guess like I actually have only been working on IBC since last May. But before that, I was hey Carlos. But before that, I was working with Zero Knowledge Validator. So I was kind of exposed to the Cosmos ecosystem, especially because they were running some privacy-related events. So they were quite engaged with Cosmos. And yeah, I guess I became Cosmos pilled and really wanted to be more involved. And yeah, then I applied for this job with the IBC Go team. And yeah, that's like kind of how I got here. So yeah, but then I would say I'm a bit more under the cover on social media. I'm more of I just look at what's happening. I'm not a massive participant. I've just never really been hugely into social media. Maybe I should make more of an effort on that part. But yeah, it's I'm just in the background maybe.
Yeah, at least get some work done, right?
yeah. Actually have responsibilities.
Yeah. I actually, when I was doing the research here, I looked you up on LinkedIn, and I hadn't realized that you've been working with Anna and her team at the Zero Knowledge Validator. And before that, you were working at Rolls-Royce, like earlier in your career. What were you doing at Rolls-Royce?
So I did an engineering degree. The first 2 years were general, and then I specialized in manufacturing. And in my first and second year of university, I did some internships at Rolls-Royce. I very much decided I didn't want to be in this traditional engineering industry. It was kind of an eye-opening experience in a way to be working in such a massive organization, but there were just so many things which didn't really appeal to my working style in general. Things are very, very slow. There's a lot more like barriers to getting things done quickly, just when you have to coordinate with so many layers and that kind of thing. But it was still like fun. I was in my first internship, I was working with jet engines, and I was doing some like non-destructive testing of turbine blades. which is like the most critical part in the engine because it goes to the highest temperature. So you really need to make sure that nothing's going to go wrong there. And then my second internship, I was
need to make sure those jet engines don't explode midair.
Yeah. Well, I think a lot of people in crypto are flying quite regularly, so yeah, they're pretty vital for that. But yeah, it's it's very heavy industry. And then yeah, I was also looking at just how I was looking at helicopter engines and how basically looking at incidents of the engines and like kind of trying to get to the root cause of where these problems came from. So pretty interesting. Some quite interesting incident reports that came through on that one, which I was like very interested to read. But yeah, it was just not my long-term aspiration, really.
Yeah, well, I mean, it's cool that you got to sort of come over to the side of crypto, and especially working on Cosmos. I want to get this out of the way because we were talking about it a little bit before the show. But you mentioned that you used to be a pretty staunch vegan, and that you've now moved away from that. And I thought that was really interesting because for a couple of years in my late 20s and like early 30s, I was also a pretty strict vegan. And I feel like, it was a point in my life where I was kind of going through some changes, right? Some like pretty significant transitions. And like looking back on it now, I can see how I was like perhaps indoctrinated a little bit by like this movement and like these people that I was hanging around with at that time. And it's and now I've sort of like totally, put that behind me, and like I'm no longer following that diet or, really like, adhering to, that ideology. I think that like I think that radical veganism is sort of like a cult, actually, and that I kind of got pulled into it. So I'm curious what your view is on that. If you feel that at some point you were kind of brought into this thing in similar ways.
So I think it was, I mean, the trigger for me to go from being kind of normal omnivore was I actually did, I was working in a sandwich factory, and I saw just like the scale of meat going into these sandwiches. And it's like, I was like, okay, this is literally one sandwich factory, and there's like, thousands of these across the world, and that's just sandwiches. So I was like, really, that was really eye-opening. And then I first just went vegetarian, and then I watched Cowspiracy, and that really made me feel kind of guilty for not going the full way. So I guess I was indoctrinated through that. But yeah, then I was like, okay, I feel it was very guilt driven. I was like, okay, I feel like I can't really live with myself not committing to this. So I was vegan for like 3 years, and I was very like rigid about it. And I think it became kind of like a part of my identity that I was like, this vegan person. And then I guess I just did a bit more like introspection, and there was some like change in my life circumstances, and I realized I was kind of like holding on to this perspective as like a part of my identity, but I didn't really actually think it was, my real identity. It was just like something which I was being very stubborn about. Not like kind of for the sake of it. I did believe in the whole ethical, logic for being vegan, but it made just normal life a lot more difficult. And especially when you're socializing and meeting new people, it's just like kind of annoying and inconvenient for them. And I just realized like this doesn't have to be a core element of me. It's like I can resonate with the values of veganism, but I just thought I'm just going to relax a bit. Yeah. So that's my story. And now I don't eat meat, but I'll occasionally eat fish and sometimes like cheese and eggs. But yeah, I was.
That all resonates with me very strongly, and I think that there's such a huge guilt aspect to that entire movement, and and also coming out of that, I realized that you know, there are many aspects of what sort of the, you know, this kind of vegan movement that has become an industry, you know, tries to pass off as good, healthy eating is actually just like horrible eating. I mean, I remember, you know, discovering these, you know, whatever incredible burgers, or, you know, this kind of like, you know, whatever, you know, mash of processed oils and whatever. And like every time I eat one, I just feel so horrible after. I felt so bad for hours. And I was like, what is this? And it's just like I think a lot of these processed sort of vegan meat like products or cheese like products are just not good for you. And the thing is, like, if you have a pretty active lifestyle, and you're not able to, you know, properly cook every single meal, and like really make sure that you're getting, I mean, I'm not a nutritionist by any means, but like being very careful about cooking just like kind of whole foods, you easily very quickly get into this you know, eating this kind of shit food.
Yeah.
And I've actually encountered quite a few vegans that were like quite overweight, right? I was like, how is this possible? How is this person overweight? And like, they're just like eating this horrible, oily, fatty
Yeah.
food. But yeah, not to make this all about veganism, because people are dropping off the live stream. But yeah, so I wonder if you can give us maybe like a brief history of IBC, if that's something you're familiar with, because I know you've been working on the project for about a year and a half. You know, do you have a sense for where IBC came from, and like how those ideas came to be, and you know, to be implemented and actively working as they are now?
So I've been a part of the IBC team for, I think now it's like 9 or 10 months, so a bit like under over a year and a half. But from like what I have heard, there were like well, so we still have like Aditya, who was one of the kind of early contributors to IBC. There was also Ethan Fry and Chris Goes, who were involved there, and Federico, who co-founded Evmos, and then also Colin, who's also still on our team. They were kind of involved with the V1. I think Chris Goes was kind of leading the team, and then he moved on to like Heliax and Enoma. And yeah, Federico also moved on. Ethan created Cosmosm. But yeah, I think they were kind of the core team. Then there were lots of other kind of involvement from other teams. Like I think Informal did some kind of formal verification of the code. I know that like Strangelove were involved in the launch very much of IBC, and I don't know exactly who was like, working on it in those early days, because this is only kind of what I've heard. But then there was the kind of whole organizational split, and, you know, people moved entities and stuff. And then Colin and Aditya moved over into Interchain, which is like where the team is now. And then the team grew. We had Charlie was an early member, and Carlos and Thomas, and then some more engineers joined, Damien, Kian. We have Addy as well, who's working on the product team with me. So I guess since that very small team, the team's now 9 people. Like it's kind of incredible to think that there are only like, you know, like kind of single digit numbers of engineers working on the protocol. And it's like when it launched, I think it was about over a year and a half ago now. I think it was like September 21, is it, around something like that? Was the not September, sorry, it was because I know that September last year was like the 18-month anniversary. So sorry, my maths on the spot's quite terrible. But yeah, I guess I can't give too much context on the history, given that I wasn't involved in the early days. But
No, but I think what Bear is kind of thinking about here, and what's interesting is that IBC has only been live for, I think, like about a year and a half. You know, since I mean, basically since Osmosis launched, right? Is really when
Yeah.
IBC kind of took off, and it's something that we had always been looking forward to in Cosmos, right? It's like, when is IBC going to go live? And when IBC goes live, it's going to be great. And like, but when Osmosis went live and IBC went live around that same time, I think everybody's minds were kind of blown as just how well this protocol was working, and how it just dramatically improved the user experience around sending tokens. And it's only gotten better since then, you know, in large part because it's been integrated in all of the Cosmos apps. So when you're using Osmosis, for example, and you do a withdrawal, the IBC transfer happens in the interface, and it's just so seamless that you sign, and your tokens end up on the other chain, and it just works so well. And to the point now where you can use IBC without really using your wallet. It's all built into applications, and I think that's really where the value of IBC really shines, is how it just improves user experience overall.
Yeah, I mean, it's like fundamentally the protocol is an infrastructure product. Like it's kind of designed to be there ultimately in the background. Like I think the best experience is like when you use these kind of front end applications which have all of the kind of the details kind of abstracted away from the user. It's like you don't have to be putting in the channel ID, things like this, which are a bit complicated if you're doing your IBC transactions manually through like Kepler. So that's why, you know, Evmos, Osmosis, kind of Axelar as well. And there's loads of other examples as well, who have kind of done this abstraction away for you, and make it a really seamless experience. But yeah, the core protocol is this infrastructure layer, which is designed for people to build on top of, and, you know, do things on top of IBC at the application layer, and, you know, have this really secure, reliable transport layer, which is not going to be at risk of you losing all your funds if you use this or something. But
well, we'll talk about that aspect in a little bit later. I want to ask you though, what is your job essentially, like as the product lead of an open source software project? What are the things that you do? And because I think when you think about a product lead, to most people, you think about a software product, or like a user facing product. Where's the button going to be? How is that experience going to be like? But when thinking of this open source product, you're thinking about code and how developers are going to be able to use those code. So what is that like, and who are the stakeholders that you need to satisfy? Who are you thinking about when building that product, and who are what are the moving pieces there?
Yeah. So like, as you said, like with a product owner, your like main concern is the users. And I guess with it being this open source infrastructure product, our users are chain developers and people that want to integrate IBC Go into their blockchain. So I spend time talking to users, which are developers, asking them, you know, how they find using IBC Go, understanding the pain points, and then that just feeds into the work to be done to improve the protocol. If there's things which are like blocking teams from actually kind of using IBC in the way that they want to. So there's like one kind of blocker at the moment, which is like a lack of callbacks from the application modules. And this is really important for using IBC with smart contracts. But this was like not kind of an original, it wasn't like one of the, kind of V1 features or like an early feature of IBC, but think little things like that, which you just find out from speaking to users of, oh, I actually wanted to do this thing and I can't, or actually we were using this and it wasn't quite as easy to do this, or it wasn't easy to understand this thing, or things like that. And then that just feeds into prioritization and planning for engineering.
Because there's two parts to this, right? There's the standard, which is a set of rules, or I mean, it's a protocol, right? So it's like how software talks to each other. And then there's the actual implementation, which is kind of the product, and that's IBC Go.
Yeah.
You're involved mostly with the implementation, not so much the protocol, right?
So like the protocol, the Interchain standards, that's what they called. So like the repository is just IBC. It basically defines the semantics of how an IBC implementation must be to actually be considered an IBC implementation. And I guess the beauty of that is that it kind of doesn't matter which like programming language you implement IBC in, as long as it's adhering to these standards, then you should, in theory, be able to have two instances of IBC communicating with each other if it's all implemented correctly. And yeah, IBC Go is just the first implementation of these standards. And that's what our team is focused on developing and maintaining.
Yeah.
And that's
Which
the one that
repos
all
do you
use.
Yeah, which repos do you oversee specifically?
The IBC Go. So it's Cosmos/IBC Go. And then the standards kind of feed into work that happens in IBC Go as well, because like new features will be specified and then they'll be implemented in IBC Go. And then there's, I think there's a couple other implementations. There's IBC RS, which is like a bit behind IBC Go, not yet used in production, but it's, kind of catching up. And then there's a solidity implementation as well, which is also not used in production, but it's so the
solidity repo, implementation.
It's not like production ready, but yeah, for like the future of IBC in Ethereum, you would need IBC to be implemented in Solidity to work there.
Okay, that breaks my entire mental model about how this works. But we're gonna, I'll follow up. I'm gonna put a pin in that, and we'll come back to it later. So beyond those 9 people that you mentioned, there are obviously open source contributors. So how many people are we talking about that are contributing to IBC and moving IBC Go forward?
Yeah, so it's also just like important to note that IBC Go is just like kind of one part of the whole IBC like ecosystem. As I mentioned, like there's IBC RS, which is IBC in Rust and IBC in Solidity. But like a key component of IBC is the relayers, which is kind of the off-chain infrastructure to actually move packets back and forth and enable chains to communicate. You don't just have the protocol alone. You also need this relayer software and relays to be operating. There's 2 relayers right now. So there's a relayer in Go, which is managed, developed by Strangelove. There's a relayer in Hermes, which is managed and developed by Informal. And then beyond this, there's also other IBC applications and middleware. Strangelove does some applications and middleware. Informal is doing IBC RS and Hermes. And then like lots of like it's a very big ecosystem. There's also like organizations like Polymer who are working and contributing actively to IBC. They contributed some work on multi-hop routing and a local host client, and they have their own kind of IBC use case for connecting non-Cosmos chains to Cosmos chains as like a router. So it's like there's really a very large like number of organizations which are getting involved with IBC related development and different kind of elements of the stack as well. And like also, the future to have more kind of cross-chain smart contracts. So like Cosmos is really relevant here. yeah, it's also I should have like basically for IBC to spread beyond Cosmos, you have a big component of light client development, which Strangelove are involved in, and also some other teams like Composable, who want to create like a Cosmos Polkadot connection and also a connection with NIR. So there's lots of like broader IBC work going on other than just IBC Go.
Wow, I didn't realize that there's so many teams were contributing back to IBC, like Polymer and Composable and all these other teams. So yeah, it's very cool. I mean, especially since I know that those teams are focused on bringing IBC outside of the quote unquote Cosmos ecosystem. And I think this is one of the really interesting things about IBC is that even though today it's mostly used between Cosmos SDK chains, there is a real effort to bring IBC outside of the Cosmos ecosystem. And I think it's also it is recognized outside of the Cosmos ecosystem as a great standard, and I think given the right implementations and overcoming some of the challenges of implementing IBC outside of fast finality chains, it can be implemented across other ecosystems as well, and it probably will be. So very optimistic about that.
Yeah.
So what are the key components here? So you mentioned light clients, relayers, and channels. Can you describe? I mean, maybe one way we can do this is like describe the life of an IBC packet. From chain A to chain B and how it interacts with all of those different components.
Yeah. So there's kind of two kind of like elements of the IBC protocol. You've got the application layer and you've got the transport layer. So the application layer.
Susannah, there's just there's a bit of noise from the wind. I wonder if
I'll
you have an
close
open window
the door.
or something.
Yeah.
Okay.
I'll just
Thanks.
close the door. Is that better?
Yeah.
Yeah. So there's two layers. You've got the application layer and the transport layer. The application layer, you'll have your specific module, like it could be token transfer, or it could be cross-chain query or interchain accounts. And this application module will interface with the channels, which is kind of like the top layer of the transport layer. And then the transport layer consists of light clients, connections, and channels. So it's like those are the key components to think about. A light client is just an algorithm to track the consensus state of another chain. And connection is just you have two chains, they'll have a connection between them built on a certain light client. And then the channel is the kind of application specific conduit for this. Like it could be for token transfer, you'll have a separate channel for queries, you'd have a separate channel for interchain accounts. So those are like the main components. And so basically,
so just two chains that have a connection would have different channels for all of those things. And by the way, those things are standards in themselves, right? So moving, ICS 20 tokens or moving ICS 721 tokens or doing an interchain query, which is itself another standard, you need a channel for each of those things.
Yeah, exactly. So yeah, each like application module will claim like a channel and be attached to that specific channel. And then
what's the process of implementing that channel? Do both chains have to implement it in their Cosmos SDK software, do an upgrade such that the channel is established is there, and then how do they initiate the connection?
So when you have two chains that both have an implementation of IBC, a light client would spin up. A relayer would spin up a light client of that chain, and the other chain would have the light client of the counterparty chain. And then these two chains would perform a connection handshake. So that's basically to say, okay, chain A is running a like client of chain B, and they're like, hi, chain B, nice to meet you. You seem, everything is checking out as expected. Chain B will then be like, hello, yes, you also look as I expect you to be. So now we can have this connection. And then if you have a specific application that you want to use, so say token transfer, then the relayer will spin up a channel as well on top of this client and connection, and then be able to send packets along this channel. So it's very like the relayer has to set up the client connection channel to use that to transmit the packets between the two chains.
And relayers don't need to be, I mean, relayers and validators are separate things. Like a relayer can just be any old, client that is relaying those packets and sending it to the chain to be included in a transaction, correct?
Yeah, so relaying is completely permissionless. Like anyone can, in theory, relay packets. Like anyone can see, oh, okay, this user wants to do a token transfer. They can see, okay, token transfer. Then technically anyone who's running the relay infrastructure can just relay this packet. However, in practice, running a relayer isn't really like a trivial task. Like you need to be running a full node of the chain, of the two chains that you're relaying between. This is so that you can update the light client that's checking the consensus state of the other chain. So you need a block header from your full node, and you construct the proof to update the light client. So it's like, in theory, anyone can do this, but in reality, it's mostly relayers doing this because it's not really trivial to be just running full nodes of multiple chains. And
You mean validators are doing this?
Yeah, because they already
because they're already running.
Yeah,
clients.
exactly.
Yeah.
Although I'd say like relaying is like more of a complicated task than validating. I think in reality, I'm not personally a validator, but from like my understanding and past experience of validator operations, it's kind of like once you have your setup going and everything's running smoothly, the most intervention you have to do is like upgrading when there's a chain upgrade and things like this. So it's like once you have a stable setup, it's like relatively stable and straightforward. I think getting a solid relaying setup is a bit more challenging, and it's also a bit more active involvement. Like it's a bit more of a challenge. And also like one thing with relaying is relayers have to pay for the transaction fees on either side. Chains will reimburse this typically, either with like off-chain funding, delegating to the relayers validator or such. But yeah, it's a bit more of a, relayers really believe in the Interchain ecosystem at this point. It's still like kind of a problem which should hopefully be solved soon, actually, with some work that our team's doing with channel upgradability. And then you would be able to add incentives to existing channels, like relayer incentives to kind of cover these costs. We hope to make the kind of relayer role more sustainable, maybe even desirable if it really works out nicely. But yeah, right now the cost falls on the relayer.
So the relayer, just to kind of recap here, because I think it's really interesting how this relayer works. So the relayer, it has a full node on both, or sorry, the relayer has a full node on one chain that he is relaying for, or on both chains?
Well,
so let's say Atom and Osmosis. Like I'm relaying IBC packets for Osmosis. Do I also need the full node client for Atom, or just Osmosis and a light client for the chain that I'm receiving packets from?
Well, so technically, so So basically, in a packet lifecycle, you have a packet going from chain A to chain B, and then it will receive the packet, and then they send back an acknowledgement to say, yes, I received the packet and everything is good, on kind of the happy path of like it's gone successful. So in theory, these two relayers don't need to be the same person. In practice, often chains are running full nodes on like both ends. So they might just be relaying both of these packets. But yeah, in theory, you only need to be, I could just be relaying on osmosis. So I'm running a relay on osmosis, and I'm just like sending packets out from osmosis.
Right. So I'm essentially watching for, let's come back to this osmosis atom scenario. I'm relaying packets for osmosis. I'm watching the atom chain, or I'm watching the osmosis chain. But at some point, someone sends a transaction saying, I want to move my atom to osmosis. They're initiating that transaction on osmosis. Or no, they're initiating that transaction on atom.
Yeah.
Where does that information come from? Like, how am I, as a relayer, receiving that information? Is it because someone is watching the atom chain and they're sending a transaction on osmosis? Like that's the part that I'm missing here.
So the application module will emit an event to say this
On which chain?
on Atom, on the hub, the Cosmos hub. So yeah. An end user would be like, okay, I want to send 20 Atom from the hub to osmosis. They interact with the application module. It will emit an event. The relay will see this event. Then they'll like update the light client and go through the whole transport layer process. And then they can actually send this packet. But basically, they're like looking out for these like transactions that users are making, and then they'll act on this. So it's okay. They're watching, basically watching out.
So I need a light as the osmosis relayer. I need to also have a light client, a Cosmos Hub light client that I can be watching the Cosmos Hub chain. So I'm essentially running kind of two pieces of infrastructure. I'm running a Cosmos full node and an osmosis full node and a Cosmos Hub light client.
Yeah, well, the light client is like on chain. It's like the relay just updates the light client with a new block header, if that makes sense. So like the light clients are like the on-chain component, and the full node is the kind of off-chain component, which relayers are running as part of their like infrastructure setup.
Okay, I understand. Okay, and when this happens, so that transaction goes through. What happens when the funds are essentially received, when that token transfer happens? How is it that I can't then spend those tokens, continue spending those tokens on the Cosmos Hub, effectively ensuring that there's no double spend between those two chains once they've finally made it on the osmosis chain?
So with this case of token transfer ICS-20, it's using the bank module, and the ICS-20 has like a lock and then mint on the other side mechanism. So basically your tokens will be locked into the bank module on the hub, and then they'll be sent over, and there's like verification that these tokens actually kind of were minted on the other chain. And if there's like a problem that the hub doesn't get confirmation that these tokens were minted, then kind of like, or there was like a problem, then the whole thing will like revert, and there'll be like a timeout sent to say, okay, these tokens never arrived, don't like kind of actually mint these tokens on the other chain. So it's like there's like verification that the action actually took place in the whole life cycle, and you can't just kind of be minting tokens like continuously. You have to verify that the user actually like interact with the application module, lock these tokens to then be minted on the other chain.
What prevents, so the way I see this is, let's say you have like two people in like different houses, and on one side someone puts something in a box and they're like, okay, it's in the box, and then they're able to provide a proof to the person across the street that they've put that thing in the box. And then that allows the person on the other street to say, okay, now I'll do an action, like I'll take my thing out of the box and give it to the person inside the house. But
that's a good description.
but here's the thing: once that's done, person in the house across the street can't be certain that the person in the initial house doesn't take the thing out of the box afterwards. So what prevents the hub in this case from minting those tokens again after some time, and in such a way that the osmosis chain would know that has happened?
Well, if you don't receive the proof that these tokens were taken out of the box after a certain time period, then the whole thing will time out and you won't then be able to like take the tokens anymore. So it's like there's a timeout period where you have to have received verification that the transaction has taken place. And if this time period is exceeded without any verification, then you like revert the whole process.
But I mean, maybe I'm not fully understanding this, but like you could fork the Cosmos SDK and all the modules, right? And have an IBC Go module that is acting normally, but in the code that you've compiled, there's a mechanism by which there's like a new transaction type, which is like unlock tokens, without like which is like unlock the tokens and like remint them. You'd have to be a malicious chain for this, but is there a mechanism that prevents that? Is there like someone who's watching the chain to make sure that the chain is not acting, that the initiating chain is not acting maliciously, like some time later, right? Like,
no, I understand what you're asking here now. So like when you update the light client, so the whole point of the light client is to verify that a transaction took place on the counterparty chain. So it's like this is like involved in the verification that some action actually happened to say, okay, then do an action on this other chain. So if someone tries to trick, like basically create this like fake verification that something happened which didn't actually happen, which would then enable me to like mint more tokens or do something like this, there is basically another mechanism of Aurelia where they can submit misbehavior to the light client. So another Aurelia could see, okay, someone tried to update a light client incorrectly. So there might be some discrepancy in the consensus state, the validator set. So there's like parameters when you update a light client to say the previous update must have a certain proportion of the previous validators that signed this consensus state in the next consensus state update. So this is like to make sure that someone's not just like forked the chain and created their own validator set, and then they're trying to say that these light client updates are real when it's actually just an entirely new validator set. So that mechanism will ensure that there's like continuity between the light client updates and they're actually kind of tracking the real consensus state of that chain. So you'd need like the validators on the chain to be colluding basically to submit a false header to like trick the verification, like to pretend something happened when it didn't, to kind of get to that situation. So it's quite complicated to do this like light client attack. Like it's not really trivial. And I think the thing, even though, you know, a lot of these app chains have like a smaller market capitalization than like Ethereum, they're really not incentivized to do like false light client updates or things like this, because all of these validators are pretty much not just validating on one chain. It's like they have their reputation, and there's lots of other things to consider.
You could have like social slashing on other chains as well, like if they were doing this. I mean,
so it's
Honey
like
talks about this sometimes.
Yeah, I think it's quite like an elaborate ploy to do, and it's even when like when, you know, like Terra was kind of collapsing, and it wouldn't really have taken that much like monetary you could have kind of bought into Terra to do this kind of attack, but like it didn't happen as well. So I think I mean, obviously it's possible to happen, but I think it's this kind of whole mechanism is why like IBC is so secure, really.
I read somewhere that IBC relies on two trust assumptions. One that I forgot what it is. That users trust the chain with which they're interacting, and the other is these fault isolation mechanisms that prevent the chains from executing malicious behavior. And the way I describe IBC to people, it's like I describe it as going from one place to another and using a bridge. So you could go from New York to New Jersey and take a bridge to do that. If you go to New Jersey, what happens to you in New Jersey is your own problem. Like it's on you for having gone to New Jersey. Like not a diss on New Jersey or anything, but just whatever. I've never been to neither New York or New Jersey, so what the fuck do I know? But yeah, basically you cross the bridge and you go to, you know, let's say like the town, right? And there's like the good side of town and the bad side of town. And then there's another bridge that takes you to like an equally good side of town. Like you could take that bridge and go to the good side of town. And what happens to you there is your problem. And then like someone else could take a bridge and go to the bad side of town. And if something happens to them there, that's their problem. But at least the bridges are not going to collapse under their feet. Like there's always a way to come back. As long as you haven't been wrecked when you're in that other side of town, you could still take the bridge and come back. And also the bridge is not going to collapse under you.
Yeah.
That's kind of the way I describe IBC to people.
Yeah. I mean, it's like, unless there is some like misbehavior, I think like a common misconception is that we hear is like people think that you can just close a channel, you know, which is just like not true. The only reason like a channel would close is in like there's really two circumstances. One is where there is some kind of misbehavior, like, you know, that there's some discrepancy, but then the light client will be frozen, so you wouldn't be able to transfer any funds like back and forth with the connection and channel built on top of this light client. And the other case is for specific channel types. So you have, for Interchain accounts, you have a need to have orders channels at the moment, and these don't support timeouts. So basically every transaction has to arrive. And if a packet, like there's some reason why this specific packet doesn't reach the other chain and it times out, then that channel will close. But then basically just means that you have to open another channel. It's like, it's, yeah, I mean, it's been a bit like a bit of a pain point, but those are the two reasons why like a channel would close, really.
And if all the relayers decide that they go offline, then that basically compromises liveness, but anybody can become a relayer. So at that point, anybody else can. So I guess that's maybe one of the, like, it doesn't compromise on security, but it compromises on liveness because the relayers are not like a decentralized network that like ensures that there's always a relayer available. But anybody could spin up a relayer and make it such that the channel would be available again. That's right.
Yeah. And I mean, although it's like not, the relayer network is not like necessarily super decentralized, there's always pretty much always coverage, and I think the relayer community is really like, yeah, they're positive and nice people, and they like actually want to, you know, if there's like a problem, like there's a buildup of packets that aren't being relayed on a specific channel, people will like clear the channel. They're kind of, yeah, actively trying to make sure things are working well. So yeah, although it's not like, yeah, exactly a decentralized network, but it generally works like pretty well.
So we talked about token transfers, and I think that's the use case for IBC that most people have interacted with so far, those who have used IBC. There are other applications for IBC. Interchain accounts is one of them. It's one that is beginning to come online now, in some cases. Then interchain queries also. There's I mean, I was in the repo, and I was kind of discovering all of these other ICS standards. So there's ICS 29, which is a standard to incentivize relayers, and there's a bunch of other ones. But maybe let's focus on interchain accounts and interchain queries. And I'm also curious a little bit about this relayer incentivization, because as it's from what I'm understanding, like currently relayers are doing this because, you know, they're idealistically driven, or they may be driven. I mean, they may be driven because they also want people to delegate to them. But over longer periods, in the long term, it's likely that the cost of running a relayer would become prohibitive if validator rewards go down, or, you know, whatever, in some future that we might need to incentivize them. Curious to understand how that works as well. So maybe let's focus on the two that most people have been most familiar with, and that's interchain accounts and interchain queries. How do they function with the IBC standard? Because just to kind of point out here, IBC is just a pipe. It can take any sort of packet. The ICS 20 is one type of packet that it can send, but interchain accounts and interchain queries and all these other standards are just leveraging this pipe to initiate a transaction or something.
Yes, I think that's quite like a nice way of thinking about it. It's like the application module basically defines all of the data which would need to go in a packet for this specific application. But like to the relayers, I mean, the packets are just bytes. It's just like data that's being passed between the two chains. Like they aren't really concerned with, you know, exactly what's required for this application module. They're just kind of like ferrying stuff back and forth. And yeah, the packet semantics for an ICS 20 transfer is going to be different as for an interchain accounts packet, or like an interchain queries packet. But then, yeah, ICS 20 was just like the first use case that everyone wanted. As you said, like kind of took off when Osmosis launched, which was like, you know, the interchain DEX. People wanted to move their Atom to Osmosis, and, you know, there were other chains live as well. But yeah, so interchain accounts is kind of like a general message passing protocol, and it enables you to perform an action on another chain from like the controller chain is how you define it. So you have a controller chain, you have a host chain. The controller chain would create an interchain account on the host chain, and then they can send messages to that account, and that account will then perform actions, is how I would describe it. Then interchain queries is, there's actually two different implementations for interchain queries. One is for kind of client-based queries. So it's actually just using a light client and a full node, and you're basically just querying some information on another chain, but you don't have to do the full packet round trip. But then this is limited to very specific queries. Like it's like the functionality is basically like limited. But then for this other query approach, it requires a packet round trip. So you like package the query that you want to perform in a packet. You then send it to the other chain. The chain will then kind of retrieve all the data needed to fulfill this query and send it back. So there's like two different approaches. But I guess the benefit of the client approach is that you don't have to have the other chain implement this application module to be able to query that chain. So with like these more advanced applications, we've seen the client queries and interchain accounts being used in production with these liquid staking protocols. So Stride and Quicksilver are the users of interchain queries and interchain accounts right now. They have a setup where they created a interchain account. So okay, liquid staking is basic. Let's take a step back. Liquid staking is, having a derivative representation of your staked asset, which you can then use in DeFi. And the way that these protocols work is someone would say, okay, I want to have the staked Atom token. So they'd like deposit some Atom into Stride, and then once every like epoch or n blocks, they basically send over Atom from their Stride chain to the hub if we're dealing with staked Atom, to the interchain account on the hub, and then they'll send a message to the interchain account to stake the Atom, and then that's kind of like how they're dealing with. You deposit your tokens into Stride, and then you receive this derivative liquid staking token back. So for the user, it's like you just deposit your Atom, but under the hood, the Atom's being sent to the hub, being staked, all through interchain accounts. And they use queries to look at like staked balances and stuff, things like this. I think they're also using queries for kind of cross-chain governance applications. But yeah, that's kind of what's being used for right now.
What I see here is, so people think of IBC and they think of token transfers as that being IBC, but what's becoming clear is that IBC is kind of like TCP/IP, where it's just, well, like TCP, it's just the token, the packet transfer protocol, and then ICS 20, ICS 721, all of these other standards leverage IBC, so they're sort of at a higher layer in the stack, and they are akin to HTTP, FTP, SMTP packets for transferring certain types of information. And it's almost a misnomer to say I'm doing an IBC transfer. It's like you're doing a token transfer over IBC, or you're doing an interchain accounts query over IBC, or an interchain query, whatever, right, over IBC. So it just became clear to me that like those are two separate things and they should be treated separately.
Yeah, it's like what the user is like interacting with is the application, like the kind of application layer, and then the application layer is underpinned by this transport layer, like all the kind of complicated, it's handling all the logic of being able to actually pass this packet back and forth and verify that this packet was, it's from like a real transaction. It's not like some someone's trying to submit a fake transaction to mint more tokens or something like this. All of this is happening in the transport layer, kind of under the hood, but the user is just kind of only really concerned with the specific application that they want to use. So yeah, it's
yeah. And tell me about this incentivized real layer standard. It's ICS 029. What's the status on that, and what does it aim to do?
Yeah, so this has kind of come out of a big kind of discussion around how, being a real layer is not like, it's not really like a moneymaker right now. It's a bit of a public good at this point. And we basically wanted a way to be able to have an end user like contributing to the cost of relaying. So this middleware would basically wrap a channel, and it would allow a user to attach an additional fee with their packet. So it would be the send packet, the acknowledgement, and the timeout. So there's 3 packets that could be incentivized, and a relay can a user could specify the additional fee for each of these packets, or if it's kind of abstracted away from the user, as they're saying, like Osmosis, Evmos have these applications where you're just using IBC under the hood, but you're kind of abstracted away from having to pick which channel and connection you're going to be using. They could just have a field which is kind of tip, and then they could distribute that to the relayer amongst these 3 packets in a proportion they wanted to. But yeah, the idea was to make something which is kind of relatively neutral. We would envision that it would be more on the end user to pay for this this service, because there were kind of some other discussions of how relays could benefit from I don't know, potentially kind of like a EIP 1559 kind of taking a proportion of fees, something like this, or whether you have some kind of block space market and relays have some kind of it was, I mean, all of these ideas were kind of possible, but we wanted to just have something that was relatively straightforward and simple, and see whether whether this would kind of contribute to solving the problem, and then if things should there be a need for a more advanced fee reimbursement mechanism further down the line, then it can be revisited. But the one big caveat on the fee middleware is that the problem is you need both sides of a channel to have this middleware added. So this meant that once you already have an established channel, you can't retroactively add this to your existing channel. However, we are going to be working on a feature, channel upgradability, hopefully kicking that off within the next few weeks, which would allow you to add this middleware to existing channels. And this is really important because, especially for token transfer, you've basically got this kind of whole fungibility problem, where if you transferred tokens from a different channel, it wouldn't be fungible with another channel, even if it's between the same 2 chains and built on the same connection, if that makes sense. So there's not token fungibility between channels, and that's an intentional design of IBC. It's part of the security guarantees. But this is then has kind of the knock-on effect of, well, if I've been transferring my tokens down this channel, and this is the canonical channel between these 2 chains, you don't want to open a brand new channel which would have fee middleware enabled. You want to retain the fungibility and all of the past state within this channel that you've kind of accumulated. So yeah, that's why we then need to enable channels to kind of renegotiate the connection handshake that they're built on. And
there's a question here in the audience that this is a regular listener of the channel, and he says, why aren't validator node operators just forced to be relayers because they're already making money from the protocol? Why isn't it just part of the deal of being a validator that you would also be a relayer? So is there something there that's prohibitive from a cost perspective, or maybe it's is it a game theory thing where validators in being forced to be relayers could be compromising to the network? What's the rationale here?
So I think just the kind of inherent nature of blockchains, and especially delegated proof of stake, you can't really force validators to do anything, right? It's because token holders have delegated enough tokens to these validators for them to be in the active set where they're getting involved with the chain consensus. And I mean, often with chains, you'll have foundations who will delegate to validators on their chain, and they'll have like a list of criteria to say, okay, we will delegate to validators who are doing XYZ, which is beneficial to our chain. So often, like foundations will have within their policy to say, okay, we're going to delegate to validators that are also running relay infrastructure. But yeah, as we touched on earlier, it's like more difficult to run relay infrastructure than being a validator. So yeah, I think it's also like, as you said, some validators are kind of using it as like a selling point for why you should choose to delegate to them as well. But yeah, it's kind of like, it's like a problem with decentralization, right? You can't really force anyone to do anything.
So I want to come back to what I've kind of pinned there for later, which was this IBC solidity implementation. So it is my understanding that IBC works when chains have fast or instant finality, because they're able to send this message and have assured that chain B knows that chain A is not going to have a reorg, and essentially that this transaction will be final, so that once chain B takes an action, it has a high level of certainty that chain A won't revert or reorg. With Ethereum consensus, the assumptions around finality are different. Liveness assumptions it has higher liveness but lower finality guarantees, where there can be reorgs, and that is inherent to the fact that Ethereum has essentially an unlimited number of validators, and Tendermint has a set number of validators, and that has an impact on finality. Not to get into kind of consensus theory here, but that's the kind of the gist of it. When people are trying to build IBC implementations for other chains, this needs to be taken into account. I'm curious, what's in the works to have IBC work with Ethereum, and what mechanisms would be in place to make up for this difference in finality between consensus? And I guess it also applies to other chains that have different finality mechanisms or guarantees.
Yeah. So I guess, like, to take a step back to make it a bit more general, just for any two chains to have an IBC connection, you need an IBC implementation in line with the specification on both chains. So if you want the Cosmos Ethereum connection, you have IBC Go on the Cosmos chain, and then on the Ethereum side, you'd have IBC Solidity. And then you also need relayer infrastructure that's operational between both chains, and you need a light client of the two chains that you want to track. So on Cosmos, you have an Ethereum light client, and then on Ethereum, you have the Tendermint light client, which would be
Comet BFT.
Yeah. Well, Comet BFT. Sorry. Yeah, Comet BFT. And as you mentioned, Ethereum has this 2-slot finality. So basically, you can't guarantee that a transaction will be in the canonical fork of Ethereum until 2 more blocks down the line have been submitted to the chain. So for the constraint here is on the light client updates. You can't use the light client update until you are certain that that transaction is actually going to be in the chain. So that's why for Ethereum connection between Cosmos and Ethereum, you'd have to wait until you're kind of 2 blocks in the future, or you can think the light client update has to wait 2 blocks, or you can only update the light client with block headers that have happened kind of 2 blocks in the past. It's kind of slightly different approaches. If you wanted to update the light client and wait 2 blocks, there is a parameter which isn't really used called the connection delay period. which is to say I would have to wait a certain period of time before I can actually use this light client update for any IBC transaction, or you could just set it up so that actually I'm only allowed to take block headers from like 2 blocks in the past to ensure that you've got like finality at the point that you want to do your IBC transaction. But that's just kind of like one problem with
I'm still here. My video is go on, sorry.
Yeah, I was like, do I keep going? Or yeah, so that's kind of like only one element, but the other elements is like the signature scheme that's used on Ethereum makes it like really quite expensive to be running a light client on Ethereum. So I think they use this ED, is it 255? So, I can't remember the numbers. They basically use a different signing scheme as is used with Cosmos chains. And this means that you have to validate loads of signatures in a really inefficient way for light clients, which makes it really computationally expensive to actually do this light client update, which would underpin the connection. So that's like another big barrier to actually having this direct connection. So it's not just like the latency, but it's also the cost. And I think, I mean, my perspective is, I think ideally, Ethereum should be supporting some kind of like signature precompile to make it less computationally expensive, or actually like having an EIP submitted which supports a different signing scheme if they really want to have kind of light client based interoperability. Which I know that as well, like the kind of finality question, I think on the roadmap for Ethereum, there is like a long-term goal to have like single slot finality. And I think realistically, once those things are achieved, it would be more realistic. But however, there are also other kind of workaround solutions. So there's like the ZK light clients, which people have been looking into, which reduce this this kind of computational cost. And Polymer also have like another kind of solution where they're trying to move this computation off the Ethereum chain, but still allow you to like tap into the like IBC semantics. So I think my view is like a direct IBC connection, although it would be amazing, is just probably not super practical right now. I think in the future it will be, but then I also think there's going to be kind of these other solutions which would work around this and make it more feasible.
Yeah, but yeah, I mean, it would be great if we had single, like if Ethereum. So I didn't know about this 2-slot finality. What is the delay essentially? Like if we were to implement IBC now with like this 2-slot finality, what's the longest it would take for a light client to be able to verify that a transaction is final on Ethereum?
I think it would be something around like 14 minutes or something. I think an epoch on Ethereum is somewhere between 5 and 7 minutes. And then if you're using like a ZK light client approach, you've got the time to construct the proof. But I think that's kind of the longer time in this whole process is going to be waiting for those 2 blocks.
Interesting. Are you familiar with some of the ZK stuff, like Polymer, and some other project I've seen is called Lagrange? They're doing like this generalized proof network. Like, I mean, looks pretty insane.
And actually, I've not heard of Lagrange. I know Polymer. Like Polymer are like contributors to IBC. Like they contributed a multi-hop spec, and they did some work on a local host client as well. They're just generally working on cool IBC stuff as well, and they have their product vision of having a Polymer kind of chain as a router, which would connect non like natively IBC chains, so like non-Cosmos chains to all of the Cosmos IBC connected chains. like an interoperability hub kind of thing. I guess kind of like Axelar, but really based on IBC rather than like the threshold signing scheme that they have.
Yeah. Well, I'd love to do one with Polymer as well. They're very heads down building, though, I feel like. But I'm very, very excited about what they're doing.
Yeah. I mean, their team's great. Like, Bo's great. There's Peter as well. They're all, I think, heads down building, very clever guys. I'm also excited to see how everything they're working on comes to fruition.
So before we wrap up here, what's next for IBC? Maybe on the protocol level, does the protocol need to evolve? I mean, if it's just message passing and most of what's kind of evolving and providing new use cases is the stuff that we're sending through it, right? Like these ICS standards. Does IBC itself have a roadmap, right, in terms of improving, I don't know, this message passing? And what are the things in terms of applications that you're most interested or most excited about?
So there's much more to be done on the protocol. It's definitely not finished. I mean, in like the next few months, I mentioned channel upgradability, which basically allows you to update the application module, which is has claimed a channel, or add middleware to both ends of channel whilst retaining all of the existing state. Really important for token fungibility. And then this means that you could add fee middleware to existing channels. So it's exciting to see what's going to happen there. Then there's new kind of channel orderings. So I mentioned with Interchain accounts, there's a requirement to have ordered channels, which would close on a timeout. As this is a pain point, it would be really interesting to look into ordered channels which allow a timeout. Also on the protocol, like one problem, like linked to token fungibility, is if you want to send your token from chain A to chain B and then to chain C, it wouldn't be fungible with a token that's gone from chain A to chain C. So basically, this would be if like a user wants to send their token from chain B to chain C after coming from chain A, you would kind of automatically route it back to A and to C so that you retain fungibility. So it's kind of like would be like a UX improvement.
Yeah, that's a big issue, right? If we could, that's something that I've encountered myself, and some workaround for that would be really cool.
So that's like on our horizon as well.
So just the problems here, just to maybe clarify, problem is if you move, say, atoms from osmosis or to osmosis and then to Juno, and then you go back into Atom from Juno, you essentially have IBC Atom, ICS 20 Atom on the Cosmos hub. You're not going to go back to Atom. You have to unwind that transaction in order to come back. And so this would effectively go back through Atom and move those tokens into whatever other chain you're back to the Cosmos hub, rather than going from Juno would come back through osmosis.
Yeah, but the idea would be that you'd never get to the point where you've got this atom that's gone,
this ICS 20.
It's like you'd only ever have like one hop tokens, because every IBC token, it's called an IBC denomination, and it has a record of the channels that this token has traveled through. It's kind of part of the security guarantees of IBC. But this can cause like UX problems. Like when you if I have my atom from the hub sent to osmosis, and then it's like, actually, I now need this atom on Umi to do some, whatever lending kind of stuff, or, this is another, I want to send it to Injective. Then, it's like, from an end user, you're just like, oh, okay, I want to go here now. But you actually have to think, if I want to be able to use the applications on Umi or Injective, my token needs to be fungible with all of the other tokens there. So you need to like unwind it. So having this kind of done automatically in the background would be pretty big win there. And there's also kind of other new channel types. So for queries, right now, both designs are like kind of request and receive. But I think having a subscribe and publicize model it's like something which seems to have a lot of interest. And a new channel type could enable this. So kind of having like a broadcast channel type where it's like people would say, I want to listen to what's coming out of this channel. And then it's kind of like push data from this channel to whoever's like subscribing. So yeah. And I think a thing that I'm really excited about, which is like we're like actually doing some work to like enable this workflow better, is for more kind of like COSM-WASM composability and having more cross-chain contracts. The like initial protocol was designed without like a callback from the application modules. So if I'm not a person calling an application, there's not right now an automated way to know that like your cross-chain transfer has completed unless you did like an on-chain query.
Okay. Well, I think her internet, we're having a lot of technical difficulties here with my camera and her internet. So hopefully gets resolved here in a second.
Hi.
Yeah.
Sorry.
No worries.
Sorry. I just, yeah, my internet just went a bit bad there.
Yeah, no worries. No, it sounds like there's a lot of really cool things coming down the pike, and really excited to see like all the applications and the application space that this opens up. And I think that in many ways it's just a beginning. It feels like IBC as a protocol is about to get a whole lot better with, you know, wider adoption of interchain accounts, wider adoption of interchain queries, and the cool things that people are going to do with that. This transaction unwinding problem that is only going to make IBC better, and the user experience of IBC will be a whole lot better. And we haven't even talked about like stuff like interchain security, which is actually also a part of IBC.
Yeah, it's also built on IBC, yeah.
Also known as CVV, apparently, which is the technical standard. Cross-chain validation. So yeah, I think we might have to do another episode at some point to get an update on all this stuff. But yeah, thanks so much for coming on. It's been really interesting, and I've learned so much about IBC, how it works, and now have even better conviction that it's, you know, one of the most important standards in the interchain, and certainly one that I think is expanding outside of what we typically know as, you know, the interchain or the Cosmos ecosystem. So it's really satisfying to see that actually coming to fruition. Yeah. So thanks so much. Yeah, thanks so much for coming on. And to our listeners, thanks for tuning in. Thanks for watching the podcast. If you enjoy this content, please consider subscribing. You can also follow me on Twitter. I'm Seb 3.0. And you can also stake with Interop. Just look for Interop in the active validator set. Thanks so much for watching. I'll see you next week.